So this is my video on trig integrals. Now, as displayed above, there are two methods which we used this year when solving for trig integrals: u substitution and utilizing the reduction formulas. Now, I will use examples getting into both of these methods one by one to display how they can be used to ultimately find the integral of a formula which involves the products of two trigonometric equations. So in this case, if we look at method 1, u substitution, we can use this method when taking the integral of sine cubed x cos squared x dx. So now in method 1, when using u substitution, specifically when you have sine to an odd power, what you can do is something that we learned from pre-calculus 12 in regards to your trigonometric identities. And then once you use your trigonometric identities, you can use u substitution to find your integral. So in this case, I will use my u substitution later, but first I will use my trigonometric identities to split up sine cubed x into sine x and 1 minus cosine squared x. Once again, we have to multiply it by this cosine squared x here times cosine squared x dx. So now essentially all I did was I split out my sine cubed x into sine x and sine squared x, and as we learned last year in pre-calculus 12, an equivalent to sine squared x, due to the fact it's a trigonometric identity, is 1 minus cosine squared x. So now if we carry this line along further down, we can now begin to utilize our method 1, which is u substitution. So in this case, I would set my u equal to cosine x, and I would set my du equal to negative sine x. So now in this case, what I can do is, because I have a positive sign here, to make it a negative sign, I would have to multiply the entire thing by -1. So I will have the negative integral of, now this is replaced as du, and then using my u's for cosine x, I would have that multiplied by 1 minus u squared, which is once again multiplied by u squared due to the fact that we have a cosine squared x on the outside. So now what I would do is I would take my u squared, and you put your u squared into your bracket. So you'll get the negative integral of u squared minus u to the 4 bracket du. Once again, we're carrying along with our u substitution. So now simply all we do is we take the integral for u squared minus u to the 4. So in this case, it'll be negative times the integral, so negative of the integral of u squared minus u to the 4, which is, in this case, 1/3 u to the 3, which is the integral or the antiderivative of u squared, minus the antiderivative of u to the 4, which is 1/5 u to the 5. So now that we've done this, we simply have to plug in for our u values, which, as stated earlier, is cosine x. And we will attain negative 1/3 cosine cubed x minus plus, because now we have to take the negative and put the negative into the bracket, plus 1/5 cosine 5x. And then finally, because it is an indefinite integral, we must remember our plus c. And that gives us, with u substitution, method 1 of this video of trigonometric integrals, to finding our integral of a trigonometric function. So our integral of sine cubed x cosine squared x, utilizing method 1 of u substitution along with trig identities, we attain negative 1/3 cosine cubed x plus 1/5 cosine to the 5th x plus c. So now continuing with our two methods for solving trigonometric integrals, we now move on to method 2, which is our reduction formulas. Now you will see here on the right hand side under this table of trigonometric integrals, we have all of our reduction formulas dependent on what we are taking the integral of. So in this case, we are going to be taking the integral of cosine to the 5th x multiplied by sine x. Now in this scenario, once I went through my reduction formulas, I chose equation 14 here for a very specific reason. So now if you look at equation 14, although it may be a little blurry, equation 14, when taking the integral of sine mx cos nx, so in this case our m is 5, or rather no, our m is 1 and our n is 5, will result in giving us negative sine to the m minus 1x times cos to the n plus 1 all over m plus n plus m minus 1 over m plus n times the integral of sine to the m minus 2x cos to the nx dx. Now, the reason I chose this one specifically is as if you look at the formula at the very beginning when it has sine to the m minus 1, we know that that will be sine to the 0 in this case as our m value is 1, which means ultimately this value here will be eliminated and become 1. Additionally, when we're adding our product of our integral within the statement, because the numerator will be m minus 1, and in this case our m is 1, this will become a value of 0, and multiplying a value of 0 times this entire chunk here will result in this whole chunk being eliminated. But I'll now show that in my work. So now if we use our reduction formulas, what we should get is negative sine to the 0x times cosine to the 6x all over 6 plus 0 over 6, as that is our m minus 1 over our m plus n, times the integral of sine to the negative 1x cosine to the 5x dx. Now, if we examine this equation, as I stated prior, we know that this negative sine to the 0x here, rather this negative is on the outside of the entire fraction, but this sine to the 0x here will result in multiplying this function here, cos 6x, by 1, as this value will become 1. Additionally, multiplying the 0 over x times this integral portion of the reduction formula will result in this entire portion of the equation here equaling 0. So now what we should get for our integral through the use of reduction formulas is negative cosine to the 6th x over 6. And once again, as stated prior, because it is an indefinite integral, we must add our plus c. And if you would like to move the fraction out, you can further restate this equation as negative 1 over 6 cosine to the 6th x plus c. And that is the answer for our integral of cosine to the 5x sine x when using method 2 reduction formulas. Thank you.